Hi guys, welcome to section 9.2. This is so exciting, isn't it? So section 9.2 is translations. We're going back to vectors. So that's why we needed to start off this chapter unusually with a section from chapter 8 because we are going to do translations using vectors. So translation is another transformation. We've got 4 in total, so this is our second one. A transformation that maps all point of a preimage to its image along a vector. So remember, a vector is component form. What does it look like? How do we travel in the x direction? How do we travel in the y direction? So we're not only going to have our ordered pairs for our preimage, but then we're going to have that vector. Notice that our vector is in that bracket, so that's how you identify that. This is also a congruence transformation, which means that although the image changes its position on a coordinate plane, it will not change its size. It is congruent. The image and the preimage are congruent to each other. And in vector AB, A is the horizontal change, in other words, the x direction, and B is the vertical change, aka the y direction. So everything feels very ordered pairish, although we're using that vector to do some work with them. So if you notice, over on the side, I've got this vector k, and k is telling you the movement from my pre-image point A to my image point A prime. So A to A prime translated along vector k. So it moved that far. Vector k may be, 6, 3 or something like that. So here's our rule. We've only got one rule for translations. It's a pretty easy one. To translate a point along a vector AB, add A to the x coordinate and B to the y coordinate. So we're going to start off with an xy ordered pair. We know that we're going to translate it along vector AB, which means that my final point for my image is going to be x plus a and y plus b. So I take the x coordinate and add how far the horizontal change is. I take my y coordinate and add my vertical change to it. So I've got this image p at negative 2, 3, and I want to translate it along the vector 7, 4. So where will p prime be located? Well, my p prime has to be at negative 2 plus the 7 from the vector, and the ordered pair 3 plus the 4 from the vector. So I know that point p prime is going to be at 5, 7. So I'm going to go over 5, about here, up 7, maybe around here, make that a p prime. In other words, p is my end point. Sorry, p is my initial point, p prime is my end point. And remember, p is the pre-image, and p prime is my image. It's weird to call it an image when it's just a point, but of course, in the first example, we will have ourselves a triangle or some other kind of shape. Let's skip let's do this one. Triangle EFG, the vertices are at negative 7, negative 1. Let's just go ahead and put those on there. Negative 7, negative 1 is point E. Negative 4, negative 4 is point F. And G is at negative 3, negative 1. So draw yourself in your triangle, EFG. And notice how right here, it's got the vector that we want to translate along. So we're going to use that vector 2, 5. If we're thinking just coordinate plane, that means that our point E is going to translate right 2 and then up 5. So I'll go right 2, up 5. That will be my E prime. G prime, I'll go right 2, up 5. And for F prime, I'll go right 2, up 5. Drawing my triangle. I'll probably ask you as well for those ordered pairs. So what is the ordered pair for E prime? Well, you could do it two ways. You can graph it and then count it out, or you can do your ordered pair from E, add the 2 to the -7, add the 5 to the -1. So -5, I can't do math, 4. F prime will be at -2, 1. Looks like it is. And G prime should be at -1. Uh-oh, 4. Oh, yeah, that's right. Got confused for a second. So one way or the other, I'll probably ask you to write me out the image ordered pairs as well as graph that. Notice my image and my pre-image are congruent figures if I did a good job drawing them, because this is a congruence transformation. What's everybody think of this? Do we need to do another one, or are you okay with these? This seems pretty simple, right? Just look at number 2. Number 2 is a square. It tells you the vertices. Notice that our vector that we're going to translate along is at -3, -4. Just watch those signs. So that means if you're going to sketch it, you're going to end up going left 3 and down 4. Or if you're going to find J prime, you're going to do your 3 minus 3 and your 4 minus 4. So J prime will end up being at the origin. So this is my point from my, is that right? Yeah, that is my point from my, I can't remember what I was going to say. I got confused for a second. So when I do that, just make sure you watch your vector to see which direction you need to go. I don't think we need to go through more examples because vectors are pretty easy. You just feel, it feels a lot like just using an ordered pair. So that is it for section 9.2. Sorry to cut it short. If you want to finish off this example and do example 3, feel free to do so. I probably should be more technical about it, but I think that you've got it. So have a great day. We'll see you next time.